Well, hi, good morning. Thank you so much for joining me in my shop. Today is March 19th, and it's above freezing, and I think it may stay that way for the most part here now. I think we can start saying goodbye to winter. Well, there still is a foot and a half of icy snow outside. Well, maybe not a foot and a half anymore. Maybe it's down to a little over a foot, half a meter. By the way, so I have 15,000 new subscribers who subscribe to me, not because I'm doing radio stuff, but because I gave a couple of stand and deliver type videos. So if you're one of them, today I'm doing radio work, and you can spot that in the thumbnail of the video because it just shows the radio in my shop. If I'm doing another stand and deliver video, you'll see me in the video thumbnail standing and delivering. So you can watch for those if you'd rather not watch a radio video. If you're a radio nut, here you go. Here's one. So things are kind of progressing downhill with this radio. In fact, I'm getting less and less the feeling that I'm on to what's wrong with it, and more that I really am missing the point here somehow. So in short, a radio appears to work quite well on broadcast band, but on every shortwave band it appears to be very, very weak. So I'm trying to find the difference between the two of them. One of the thoughts that came to mind, the difference between the performance of the broadcast band and the shortwave bands. So maybe my conclusion about the radio must be working quite well for the broadcast band to operate, maybe that's wrong. Maybe what's really going on here is the radio is weak all the time, but I'm providing it with a very strong broadcast signal. I don't think that's the case. I think it is working well on broadcast. That's what I think, but I'm doubting what I'm thinking. That's what I'm trying to get at. One of the things that was noted during the IF alignment was adjusting. I think it was this screw. This trimmer made no effect on the radio at all. That's a curious thing, it could possibly relate to trouble inside this can. I don't want to dig inside here until I'm quite convinced that I have to. There's not a lot in there to do stuff with. Maybe just some coils and the two trimmer capacitors up here. Broken wire inside there. I don't think the AM radio would work at all if that were the case, the broadcast band. So I'm really quite confused about all this. I was in here yesterday studying the schematic, trying to come up with some yesterday evening, trying to come up with some sensible way forward, and I did come up with an idea. For the life of me, I can't think of it now. So I'm going to stop for a minute and try to make that apparently or supposedly good idea come back into my head. Okay, I did remember. Here's what I'm going to do. I'm going to try to determine the frequency of the local oscillator on each of the shortwave bands relative to where it should be. So in other words, I'm going to, for instance, get on the 19 meter band, tune in 15 megahertz. The local oscillator should be 15 megahertz plus 460 or minus 460, one of those two. Interesting to find that out also at the same time, and see that it isn't it is in the correct relationship, 460 kilohertz away from the tuned frequency. If somehow all the shortwave local oscillators are shifted out a long distance, then the radio would perform exactly the way it is performing, or something like the way it is performing. So this is more a question of eliminating a long shot possibility, just to get it out of the way, because I would be so surprised if we find out the local oscillators are all off by some huge amount. That would be quite surprising. But first, coffee time here. Okay, so up here you're seeing my SDR radio. The SDR radio is actually sitting just over here. This is the antenna. This is the antenna. It's the antenna. If I this is not working as the antenna. Yeah, I think it is. Yeah, definitely. Yeah. So you can see I've just got a clip lead coiled up here, and all I'm going to do is move it around the radio until I can see the local oscillator. I'm going to start with the broadcast band, which I believe is working. Certainly we'll be able to find the local oscillator. I'll be able to find a good place to stick this. Probably like that or like this or something. Then we know in this position, this coil will pick up the local oscillator, display it on the SDR. Then we'll go through the shortwave bands one by one and see if it doesn't show up each time. Okay, that is the plan. So first thing is to turn on this radio. I have it on the broadcast band already. Away we go. Everything is normal. Now there's no antenna on the radio, so I am going to be the antenna briefly, just to convince that it's working here. That's convincing enough. Uh-oh. Here comes one of my assistants. Here he comes. You just blowing through, or what are you doing? Just going through. See ya. Okay. Local oscillator on the SDR. So I noticed, oh, the SDR showing a lot of different signals once I turned on this radio. Well, there's something really tall on the SDR. I can see it right around 1250. I'll tune the radio and we'll see that 1250 is up above my finger here. I can point this way. There, I can point with this. No, yes I can. So you can see this. This is probably the local oscillator. And now we're just gonna move it here. Yeah, he's taking the high route this time. Tune the radio a bit and watch the oscillator move back and forth. There it goes, back and forth. So now we'll try a few different locations with this coil. Get it out of there. You can see the local oscillator signal is quite strong. It's just about everywhere. Explain that. Okay, here comes another one. Coming through. This is brother. First was Wally. Here goes Bert. Passing through. Just see ya. Have a nice day. Okay. So I'm pretty sure this is going to be just a fine position for it. Let me jam it in here because I don't want it moving around. There we are. Okay, now we'll go to the next band up. Next band up. So on this band, well, we'll go to the low end of it. That's around 6 megahertz. Change the SDR to show around 6 megahertz. So maybe that's it right there. I'll tune the radio a bit. No, it's not moving. So that is not it. So the radio. I'm just watching my cat here as he ventures through my shop. Okay, everything's okay. So if we just keep tuning this, at some point the local oscillator should show up. Let's go up a megahertz here. Huh. No, I don't see it. So the bottom of this band is, I gotta look at the, move your tail there, cat. The bottom of this band is 6 megahertz and a touch below. So if we just tune it up a little bit to get it right off the bottom, like that, that should be somewhere around 6 megahertz. Okay, if it's 6 megahertz, then it should be 460, which will be right in here. I don't see it. Or it's going to be under. Maybe it's under. So that would be 6 minus 460, so that would be somewhere in here. Well, there are some signals in there. Okay, let me tune the radio and see if any of them move. Nobody's going anywhere. Now this is kind of weird. I saw the local oscillator on the oscilloscope. Didn't I? We're running the radio with 107 volts coming in, so it's not under voltage. What are the chances I'm just not doing this right? That I've okay, that's got to be the first band. The capacitor is closed, so it's got to be at the low end. So it's got to be around 6. Wow, there is no local oscillator. I'm having a hard time believing this is true. That's what's happening here. Let's go to the next band up. Next band up is I gotta look on the radio here. Next band up, it starts at 9.5 at the low end. So we'll close the capacitor. 9.5, so we should go up around 10 here. Whoops, up around 10. Okay, lots of signals here. Now if I tune the radio a bit, we should see something move. Well, oh my gosh, here we go. It's just the craziness stuff. Yeah, somebody interpret that. So I believe the local oscillator is right here. Is this thing right here. And everything else is gibberish coming out of the radio. So we see a local oscillator on this band. I don't have any doubt that that's it. We'll go up another band. Now we're on the 11, so it's close to 11.6, so that would be close to 12. So if we go like this, and this is probably it right here, the big signal. We'll tune the radio and see if it moves. Yes, it does. Everything else is moving too, but just ignore all that other stuff. These super heterodyne radios, as I'm concluding, okay, I'm not absolutely sure, are filled with these spurious signals, and occasionally I think they do interfere with the operation of the radio, but mostly you're unaware that these things are happening inside the radio for reasons I won't go into. Okay, so a local oscillator, it looks stronger. Let's go up another band. Okay, now we're on the top band, 14.9 at the bottom, so 15 plus 460, so 15,400 or so we should find. Oops. 15,400 would be right around in this area. Look at all the stuff there. What is all that? Okay, I'll tune the radio. That's me touching the chassis and letting go again. Huh. Okay, so that tall thing from which all the other signals are spreading out is the local oscillator, I'm sure. So it's present. Isn't that strange? All these weird signals that are produced by a radio like this. And what's happening at this point? I really don't know. Let me turn the volume up. What do we hear? It is up. I don't hear anything. Nothing audible. But just tuning back and forth and looking at the funny patterns that it makes. So I've tried, I've been seeing this now for years since I started using my SDR, and at first I thought it was the SDR radio itself that was doing this, and it's possible it is. But I think it's the radio itself. I'm just tuning back and forth a little bit. Now a whole group running around in different directions. By just tuning in one direction, you can tell the local oscillator is just drifting upwards as I tune. Isn't that something? Someday I will fully understand what all those signals are, and it'll all make sense to me, but it hasn't yet. I just have a vague notion that it's signals getting mixed together in the mixer. Whatever's in the mixer gets mixed. Hey, what's happening there? I'm not moving. What happened there? Don't know exactly what happened there. Okay, so enough. I'm having fun. It's time to stop having fun with it. And what have we concluded here? Well, we've concluded there's a local oscillator operating roughly the correct frequency on every band. Appears to be of a similar strength, appears to be strong enough to do the job. So that's not part of the problem here. Well, okay, I've eliminated something, but I kind of already knew. It really, coffee time, yeah, that's what's really needed here. Who's here with me? Oh, both brothers are here. Okay, boy, I used to take my coffee breaks to kind of calm down, but now when I go and sit in front of the TV, I don't get calmed down at all. I get totally wound up. Here, what's going on? Just passing through again? Just zooming through? Gonna stay for a while? Why don't you stay for a while and help me calm down? Help the whole world calm down. You gotta calm down. No, this is not the calm down time, is it, for you? No. There he goes. Zoom. I guess they're in their active phase. For about a half an hour, they're going to be very active in here. Oh my gosh. Help me, somebody. Okay. What to do next? Good question. Let's tune up a shortwave band and mess around with it a little bit and just see how weak this really is. So you're coming this way now, are you? Thank God I got these cats. If it wasn't for these two cats, and our big one too, our third one, I wouldn't have anything to balance out the tensions of life. I don't want to get into all that. Trying to do this to stay calm. It's not working very well. Okay. You know what I haven't done? I have not checked the various tube pin voltages in here. Gee, that might be a good thing to do. That might be yeah. I should have probably done that earlier. Let's get through that today at least. Verify that the voltages are correct inside the radio. So the information, the service information I have for the radio and the schematic and that don't give any hint as to what voltages should be in this radio. So what I'm going to do is I'll go tube by tube with the radio operating. I'll look the tube up in my book, and then we'll follow the recommended typical operation voltages here and see if what's in the radio is you know, close to what's in the book here. Again, if there was something seriously wrong with this, I would think the broadcast band wouldn't work either, but I'm kind of trying to ignore that piece of logic at this point because I don't think it's helping too much. So, okay, well, we'll do that next. Along with watching TV and finding it so disturbing, and I'm sure it's no different for you, whoever you are, wherever you are in the world. I'm also getting emails at a fairly steady rate from Americans who have watched my recent Stand and Deliver videos. And the emails are terribly upsetting, and not because Americans are mad at me, not at all, it's the other way around. As I read them, it makes me almost want to cry. People are so frightened in the United States and they don't know what to do. Yeah, that's what I'm getting in emails over and over and over. Hate the man. Shame on me for even bringing it up, but it's so hard. I'm telling you, it's so hard to not have this in my head. You know, the most powerful country in the world in history is threatening my country with disaster. And everybody else too. Jim, okay, I gotta stop here. Let's get busy. That's the best thing. Get busy. So 6F6, we'll start with that tube. And I've got the diagram here, a 6F6 beam power tube. I'm looking to see if it has a screen. Yes, it does. And of course a plate. And 3 and 4. Plate and screen. 3 and 4. Let's look at the voltages on there. 3 and 4. Just get a little more light on it here. Okay, pin number 3, and this is the voltmeter we're using here. And I should turn it on. That would that would be helpful. We'll set it for now 150 volts full scale. Set to DC here. Okay, we're ready. 3 and 4. So we'll look at 1, 2. This is 3, so this is the plate. This should be the highest voltage in the radio. More than 150. Let's try it again. 1, 2, 3. Maybe not quite the highest voltage in the radio, but the highest tube voltage in the radio should be right here. So we're on the 500 volt scale. It's just under 300 volts. That's a pretty healthy voltage. Now we'll look at the screen, which I believe is right next to it here. Is that any different? So this is 270. And this is 290, about 20 volts. Maybe 20 volts dropping on the, I don't know. I won't talk, don't talk. So what's the book say? What does the book say? 6F6. Typical operation, plate supply voltage. 250 or 285. And so we're up around 285. So using the 285 number, this is quite interesting, we should get screen voltage also 285. Okay, we're just a touch below it. And the grid bias should be something like minus 20. Minus 20 to the cathode. Which, the cathode is grounded, isn't it, in this radio? So I should be able to just read the bias voltage. The bias voltage is coming from the power supply itself. Oh, shoot. Close the book. Noting what 6F6, what the grid is. 6F6. EF, G, EF. 6F6, the grid is number 5. What's the voltage on 5? What's the voltage on 5? It's going to be a negative small voltage. This is not the best way to measure it. 1, 2, 3, 4. I think this is 5. Yeah. So we got 15 volts negative. That's good. So that means the voltages on this tube are appropriate. Okay. Very good. Now the next tube along, might as well just do them in order along here. So that'd be this tube. Hey, what's going on with the focus? Sometimes the radio gets oh, what is going on here? Okay, well we're back in focus. So I hope that wasn't out of focus for too long. Next thing. We want the meter in view, and the next tube. That's right. I was trying to. Next tube is a 6K5 audio tube. I'm not too worried about that, but let's take a look. 6K5 being used as an audio amplifier. 6K K 6K5 high mu triode. Outline section, blah blah blah. No, it just has it listed here. Heater volts 6.3, characteristic plate volts 250 max, grid volts -3, amplification factor 70, plate resistance 50,000, transconductance. This is a discontinued type. Wait a minute. There's no screen, so all it's going to give is the plate voltage 250 max. I don't know what it would be on this tube necessarily. Interesting. 250 max. Okay, so that's this guy here. Oh, I've gone and not noted what pin it was. 6K5. Grid is, oh, it's a grid cap. Yeah. Okay, we're gonna, again, this isn't the best way to do this. Well, what are you doing, Jim? What the heck are you doing? You know what it is? It's I can't help but keep flipping back to the situation that Canadians find themselves in with, the country they used to be, basically our big brother. I hate to say it that way, but certainly felt that way when I was younger, and I think maybe other countries felt the same way. Big brother United States. Not that Canada tried to model itself after the United States 100%, not at all, but certainly on some big things, yeah, sure. America in the lead. Not anymore. Not anymore. Plate 4, that's what I want to know. Plate 4. stop talking about politics, Jim. It's not politics, it's international relations. Politics is reference to a game, isn't it? Did I say 3? What did I say? Oh my God, I'm back to where I was before. I can't think straight. 1, 2, 3. Plate. Plate, 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 plate. Plate, plate, plate. Ooh, okay, very, very low here. Maybe I booped up. So here we're looking at a 50 volt scale. We're looking at 30 volts on the plate of the audio tube. That doesn't seem right, does it? 30 volts. I think I'd probably, I'd go take a break, you know, to clear my head, but it won't clear my head. I'd have to watch cat videos. They actually do that. Even though I have cats, I will watch cat videos to lighten my mood. It really works. 6K5. Maybe that's why you're watching my videos. 6K5. Here we are. What am I looking for? What am I doing? Who am I? Why am I here? 250 max on the plate. We're nowhere near that. The plate is 3. So we might have something going on with the audio tube, but that's not the kind of problem that we're having with the radio. 250 volts max. I can't imagine that you would really want to operate the radio at 30. Again, just double checking here. 1, 2, 3. This be it here. Whoops. I'm definitely on the 50 scale, so that's that's 30 volts. That's worth looking into. But again, it's the audio tube, and I don't think that can be part of the problem. Okay, next tube. Next tube along the way is a 6J5. 6J5, eh? J5 medium mu triode. Again, no screen, just a plate on pin 3 again. 6J5 pin 3. 6J5 pin 3. 1, 2, 3. Wow. This can't be right. This can't be right. So we've got rectifier output audio next tube. 6J5. This is the detector tube being used in a very unusual way. Oh! Oh yeah, that's right. Used in an unusual way. The grid is the plate in this tube. The grid is the plate. The way they were operating it in this radio. 6J5. Haven't encountered that very much. So in this case, 5. Pin 5 should have some kind of B plus on it. Pin 5, this tube here. Pin 5. 8, 7, 6. Oh yeah, 5. I think it's this. Really? You know what? There's not going to be any voltage here. This is a diode. It's working as a diode. It's working as a diode, so all it gets is the signal voltage, an AC voltage at 0 in the middle. No plate voltage. The reason I'm thinking there must be a plate voltage is because in most radios, this is a dual-purpose tube, and it has a plate voltage on it for the triode section of the tube. But in this radio, those two functions are separated into 2 tubes, and then the detector is operated in what might be considered a weird way. Okay, so I don't think there's anything wrong there. So we'll go on to the next tube. So that's this one here. That is a 78E. 78E. That tube would be old by the time this book was published. 78. Way back here. 78, remote cutoff pin tode. In case you're wondering what that means, remote cutoff, that means you need a really tremendous bias on the grid to cut the tube right off. And what it's referring to is its characteristic curve has a straight part, but then it has a curved part that never reaches cutoff. And that makes this tube really useful for AVC purposes. Glass type used in RF and IF stages of radio receivers, particularly those employing AVC. The tube requires 6 contact. Plate. Where's the plate voltage? This type is identical to the 6K7, except for capacitances. 6K. So we're looking at a 6K7 now. Is electrically identical, but the pin layout may not be. Okay, so I'll keep my finger here. I'll go 6K7. Isn't this exciting? This is exciting stuff, eh? 6K7. Okay, so let's look at the pin layout here. It has a grid cap, cathode on 5. Well, that's it. Cathode on 8. So they don't match, but their operating will match. So if you want to know a good plate voltage, you can practically guess it anyway. But here we go. Plate 300 max, 250 as a class A, 250. So we expect a couple hundred volts anyway. Could have told you that right from the start. Okay, here we go. And how many times do you make the same mistake? I forgot to look at where the pin is. This is a 78, right? 78. And we're looking for the plate. The plate is on pin 2. Pin 2, keep the book open over there. That's 78E, pin 2. I think I count them 1, 2. I think it's like this. This would be the plate. Are we ready over there on the voltmeter? Yeah. This will be the plate. Right here. Oh my gosh, right over. Wow, this has got a high voltage on it. So that's 270. So that's okay. That's good. Nothing wrong there. We have one more tube to look at, and that's the first tube in the radio, 6J8. This radio's full of tubes I seldom see. 6J8. That's the cats behind me. We're attempting to reconstruct something. 6J8. So we have 2 plates in here in the 6J8. 1 plate, and we have screens. So we got everything under the sun here. So I can look at this busy tube in here. So let's start with the plate. It's on 3. 1 is on 3, and the other plate is on 6. 3 and 6. Don't close the book. That's good. 3 and 6. 3 and 6. 3 and 6. Okay, so 1, 2. This is 3. Oh, make me jump. 3. That's 3. So we've got a voltage of, I'm on the 500 scale, so about 270 there. Okay, that's pretty much all of it. And the other one was 6, wasn't it? 3, 4, 5, and 6 would be here. And we have a little less, which is just fine. I think that's just perfect. Okay, so that's a measuring of the tube voltages. They're all within range and seem normal. I kind of like doing this kind of stuff, even if it doesn't lead to anything discovery, because it forces you to kind of review the radio and learn more about it and get more, realize more about it. Still not working though. Or is it? I'm going to play this radio on an antenna after this and reconvince myself it doesn't work. Okay, let's give this ugly radio a go here. So you can see I put his knobs on, because I thought the radio might feel better if he had his knobs. Maybe that'll help a little bit. Okay, here we go. So we're on the broadcast band. I have a good outdoor antenna connected. Let's just listen to the broadcast band, reassure ourselves the radio's operating. You know what? Like, this had a lot more volume before. Yeah, it had a lot of volume for a while. For a while. That's all I got going on it. That's really... Well, maybe I'm on a weak station out here. Yeah, that's probably what it is. So we'll head for the bottom of the band. No, the volume is dropped way off.
I think so, but actually the pet pharmacist dispenses competitive prices, and they're local. So pick up at the drugstore or have your prescription delivered.
Competitiveness and that energy that needs to buoy everybody up, you know, and I think there's been a lack of that. I don't mean there's been a lack of intensity or interest from the top guys, but it's I don't even know how to put it into words. It's a feeling that, you know, just collectively rises everybody to a different level. And that's what I was saying about...
What's he talking about?
You know, you had a long stretch. The season goes through the ups and downs.
Sports.
Of, you know, what, 11 of 13 on the road. Well, that's...
Yeah. So that's 590. That'd be 590, the sports channel. And this is among the very strongest stations I can get. And look at that.
You gotta... This to me is the great...
Where did the volume go?
Playing at their best. You can see it within their lineup. Everybody is jumping at a higher level. Everybody has...
Okay, next band up. Now, we're at the low end of the band, obviously. But we might be able to receive some stuff up here. That's full volume. Wow. That's the sound of deadness for sure. Next band. This is the 9 megahertz band. And there's one strong station usually operating, very, very strong shortwave station. Maybe down here. Oh, this radio's as dead as can be. Oh my gosh. Okay, next band. They all sound the same. Dead. Well, maybe, I don't know, did I do something to make the situation even worse? Is a tube literally failing while I'm doing this? And the weak tube has gotten even weaker, but it's working on broadcast. Wow, it's a 0. It's a 0. It used to not be a 0, now it's a 0. Okay, just we're operating with 106 volts, and I definitely hear a little bit of a difference there. Is there any chance I don't have the antenna switched on properly? There's really not much chance of that. Nope, I can definitely tell that the antenna is connected there with the switches the way they are. Wow, okay, we're going in the wrong direction here with this radio. I'm fixing the parts and checking stuff. Everything's checking out okay, but it's working worse and worse. as I proceed along. Okay, well that's it for today. You're watching me slowly kill this radio completely. So the important thing about this radio is I'm going to donate it to my barber shop. So the barber shop can have this nice radio sitting in it, and I'm going to get some free haircuts out of it. That's the plan. And boy, do I need a haircut! Holy smokes! So it's important I make this thing work. Very kind of surprising at this point. I don't know. Well, you know what we should pursue tomorrow is the. Wow, it's ready to receive. There's just nothing coming through here. So when I did the IF alignment, I discovered this screw had no effect. Everything is focusing in on this spot now. How the broadcast band operates with a problem that is stopping the shortwave band here, I don't understand that. That doesn't work for me. So, but it sure looks like something going on right in that IF can. Okay, we'll leave it at that for today. Thanks a lot for watching. Sorry about my momentary lapse of sanity, but it's inevitable. It's inevitable here that all of us in Canada are so upset at what once was a friendly, helpful country, which has now become a predator. How weird is this? Thanks a lot for watching, and see you on the next video.